Guys, this is Miss Colclough, and today we're going to have our first video lesson. So I need to explain some things right before we begin. I'm always going to start each video off with this page that kind of has an overview of what we're doing, the date, and the name of the lesson, and the name of the notes. This is the name of the assignment in Google Classroom. Okay. Sometimes I have these other little post-its with other things you might need to know, like for instance today, since it's our first time, I've got a little note here of what you're going to need right now. So you're going to need to have your notebook out and a pen at least and some colored highlighters. I do a lot of color coding with steps and things so that you can make the connection between what step looks like what in the solution. What you're going to do today, you're going to watch this video, and while you're watching the video, you're going to take notes along with me. When we're done, you're going to upload a picture of those notes into the Google Classroom under today's assignment, and that's going to be your participation grade and your attendance for today, okay? So that process is just like when you uploaded your work from the pre-assessment. You should use Cam Scanner to take a picture of the notes because it will make them all into one document instead of bunches of documents, and that's a lot easier for me. It makes it into a PDF, which is also much easier for me to write on and give you some feedback on, okay? Probably in the beginning, I'm going to look at your notes and maybe give you some feedback. I really do want you to do a good job of taking your notes, and the way I do this is I don't give tons of notes. I don't expect you to interpret what you're supposed to write down. I want you to write down what I write down. We're generally going to write down steps and examples, and I work really hard in Math 1 to make sure that the things you write in your notebook are the things that you're doing for your assignment. So the examples we're going to do today are problems that are exactly like will be on your assignment. Okay? So after this lesson, you have an assignment that's given to you today, and the assignment will be due by Friday at midnight. Okay? This week's assignment is going to be on deltamath.com, and at the end of this lesson, I'm going to put up the sign-in information for that, and I'm going to explain that a little bit more to you, okay? Okay, so now, another thing to know about online note-taking is that it is different from taking notes in a classroom. In a classroom, I probably will go really slow. I'll give everybody plenty of time to write everything down before I move along. And I know some of you probably have always thought in class, this is frustrating. Why are we going so slow, right? And other people are like writing slow and they're like, whoa, hold on. I'm not getting all this written down. Okay, so with video notes, you can just pause the video. If you're taking notes along with me and you're keeping up, you don't need to pause the video. I am going to go pretty quick though. I assume that everyone's going to have to pause because on this video, I have already pre-written some of the notes so that the video won't be so long. So what I'm expecting you to do is when I first turn up to a new page, that you pause it and you go ahead and write down whatever I've written down. Once you get it written down, start the video, then we can talk through it, and I'm going to do the examples live with you, okay? So that way the video doesn't take up 45 minutes. The video might only be 20 or 30 minutes long, but you might take 20, 30, or 45 minutes to do it because you'll have to pause to do your notes, okay? But I'm trying to keep the video as short as possible. Okay, so right now, the first thing we're going to do in your spiral notebook is to just open up to the first page, and we're going to make a table of contents for Unit 0. Okay, and it's Unit 0 because it's really review. Okay, so here here's the table of contents. Normally I print something that you can write on and you just glue it in there, but since we're remote, we're going to have to just write everything, okay? So Unit 0's table of contents. Page 1 is fraction operations review. So pause the video, make your table of contents, and flip to the next page, and we'll keep going. So this is what I meant. I have already written down a lot of stuff on my page that I want you to copy. I'm going to try to zoom down so you can see it a little better. Okay, we're going to review all 4 operations for fractions and make sure we're all on the same page with how to do this, how to write it, and we just remember because fractions are a really important part of linear functions, and that is the biggest chunk of Math 1. So it's something that you need to be solid on before we move along. So here I am. I've got I made 3 columns on my page, And the left side just tells what operation we're doing. The middle column is going to be the steps for how to do it. And on the right, we're going to do examples in just a second. So for steps 1, 2, and 3, I want you to pause and get that copy down. And then I'm going to move down so you can copy the rest of this page. And then we're going to do the examples. So pause. Sorry. Okay, we got steps 4 and 5 now. Pause the video and copy down your steps 4 and 5 so that when you start the video again, you're ready to do the examples with me. Okay, so let's go. Everybody's got everything copied down for this page. So we're going to go back up to the top of the page and we're just going to start talking through the steps and we're going to do an example, okay? So to add and subtract fractions, the most important thing is to have a common denominator. If you look at a problem and you already have a common denominator, then you won't need to do step 1. I think most people probably remember that, right? But finding a common denominator or the lowest number in both times tables is your step 1. So let's start an example as we go through the steps. So our example number 1 is going to be 3/5 plus 2/3. And it's a relatively simple example, right? What we're going to do, and some people are pretty good at this, and you're like, I got this, I know how to do this. Other people are like, I've never gotten this, and I always struggle with it. So I'm going to try to give you a method to use if you've struggled and you need a way to do this. If you have your own way of writing this and you know how to do it, that's okay with me. I'm just giving you in your notebook maybe a new or different process of writing it down. Sometimes people just need to stumble on the thing that makes sense to them over the years to get this to work. Okay, so finding a common denominator means taking the two denominators, 5 and 3, and I'm going to write out a few terms of the times table for each one. So the 5 times table is 5, 10, 15, 20, 25, 30. Okay, I got a few terms written. Now I'm going to write the 3 times table over here, 3, 6, 9, 12. When I'm writing the second one, as soon as I get to a number I see in the first list, that I can stop, right? So 15 is in, so 15 is going to be, it's the very first number in both lists, so that's going to be our common denominator. So here's where we start highlighting, okay? Step 1, I'm going to highlight in orange, and over here where I did step 1 is where the 15s are, right? I wrote out the times tables and find the first number the same in both lists. So step 2 is to determine the multiply number. Okay, some people have trouble with this, but all you have to do over here at your times tables is to count which number in the list the 15 is, and I'm going to show you what I mean. 5 is the first number, 10 is the second number, 15 is the third number, right? That means that 3 is the multiply number for the 5 fraction, right? So I'm highlighting in pink for this step, and the 3 is my multiply number for the first fraction. I'm going to do the same thing on this other one. 1, 2, 3, 4, 5. So that means for the second fraction with the 3 as a denominator, 5 is the multiply number. So I'm going to write those over on the problem, right? Multiply, step 3 we're at now. Multiply the numerator and denominator by this number. And by this number we mean the one we found in step 2, the pink one. So we're multiplying by 3 on the top and the bottom for the 5 fraction, and we're multiplying by 5 on the top and bottom for the 3 fraction. Okay, so the step 3, I'm going to use green. Okay, so I'm showing here that I'm multiplying by that number in the numerator and the denominator. So now I'm going to actually do it. 3 times 3 is 9, 5 times 3 is 15, plus 2 times 5 is 10, 3 times 5 is 15. So I've created my new problem with the common denominator, and now I am down to step 4. Step 4 says once the denominator is common or the same, then you just add and subtract the numerators and keep the denominator the same. So step 4 is blue for me. I am going to add the numerators right now. So I'm going to get 19 over 15. Add the numerators, keep the denominator the same. My last step is always to see if I can simplify, right? Step 5 down there. See if you can simplify your answer. Okay, you cannot always do that. The way to do it is to take the lower number, so 15 is the lower number, and say, is there any number that goes into the lower number that will also go into the higher number, right? 3 will go into 15, it will not go into 19. 5 will go into 15, it will not go into 19. 15 will go into 15, it will not go into 19. So none of the numbers that will go into the lower number will go into the higher number, so that means it won't simplify. This fraction is improper, 19 over 15. So we could make it into a mixed number, and a lot of times in elementary school you do that. But in algebra, we're usually going to keep it improper until we finish up our problem. So right now we're just going to keep an improper fraction. The only thing we're going to do to simplify is to divide it down if it will divide, but we're going to keep it like this otherwise. Okay. Step 2. Our fraction here is negative 6/12 minus negative 12 over 15. We're throwing, sorry about that, we're throwing in some positives and negatives just to kind of review that a little bit, and because on your homework you're going to have some problems that require you to remember your integer rules for addition and subtraction in addition to being able to do the fraction. Sorry, I'm having trouble getting the stupid camera right. Okay, there we go. Okay, so first step was find the common denominator by writing out the times tables. So I'm going to go over here, and if you need to use a calculator for the 12 times table or the 15 times table, you can. If you need to do that. 15 times table is 15, 30, 45, 60. Oh, there it is. It's 60. So step 1 was orange. So I'm going to highlight this number in orange because that is my common denominator. I'm going to count down to it, and that is step 2, my multiply number. So my multiply number for the 12 fraction is 5. So I'm going to write my multiplication problem there. The multiply number for the 15 fraction is 4. So now I'm going to go ahead and do those multiplications and get my new problem written. Negative 6 times 5 is negative 30. The bottom is not negative, right? We usually, in a fraction, keep the negative number with the top. So if it's written just out front like this, we generally use it with the top number. Okay? So the bottom, 12 times 5 is 60, minus negative 12 times 4 is negative 48. So I've kind of moved the negative up with the top. And the bottom is 15 times 4 is 60. Okay? One important thing that I need to remember right off the bat to get this problem right is I've done all the hard work of getting the common denominator, but minus a negative always changes to plus positive. Okay? No matter what method you have used to memorize that, some people say keep, change, change, keep the 30 negative, change this to plus, change this. Some people have just remembered that minus negative changes to plus positive. Some people have known a method called two strokes, where you have subtraction. You always use two strokes to change the problem. One stroke changes the minus to a plus. The next stroke changes the sign of the number. Okay, so whatever method you've used is fine, but we just got to remember that. So I'm going to rewrite the problem. Am I always going to do that? Probably not, but in my notes, I want to make sure that I'm really clear about what's going on. Okay, I changed minus negative to plus positive, so now I'll do the right thing. Okay, another thing to remember is that now you're adding a negative and a positive. When you're adding different signs, the numbers actually subtract. Okay, I'm going to put a little note here with my red pen. when you're adding, same signs add together, but different signs subtract. So we're actually going to subtract the 30 and the 48. Okay, we're always going to do the high minus the low. 48 minus 30 is 18. And then we ask ourselves, what sign should it be? The sign is the one that had more to start with. So 48 has more. So that means it's positive 18. So we got 18. We're adding our numerators since the denominator is now the same. I'm highlighting. Okay. And we keep the denominator the same. Okay, I'm going to go back. I skipped highlighting numbers 3. Multiply the numerator and denominator by your number. Okay, I just want to keep all my steps highlighted so that I can see when I look back at it what I did. Now I am going to simplify this, and I can see right away that we'll simplify because both of the numbers are even. They end in 0, 2, 4, 6, or 8. So I know that I can divide by 2, but I'm not going to do that right away. I'm going to check to see if another higher number will go into it. So let's see. I checked the lower number, right, 18. I'm going to use numbers that go into 18 and check to see if they go into 60. 2 does, right, but I want the highest number possible. So 3 will go into 18, yes, and it will also go into 60. 4 won't, 5 will not go into 18. 6 will go into 18 3 times, and 6 will go into 60 10 times. Okay, 9 will go into 18, but 9 won't go into 60. 18 will go into 18, but it will not go into 60. So I found my number is going to be 6. I'm going to divide the top and bottom by 6 because it's the largest number that'll go into 18 that will also go into 60. So now I've simplified this fraction. 6, 12, 18. So that's a 3. It'll go in 3 times. 6 will go into 60 10 times. And now I just say to myself, what numbers go into the lower number? The only number that goes into 3 is 3. Will 3 go into 10? No. So that means I'm done, right? I always want to check because at that step, if by chance I didn't get the highest number when I divided by 6, I would be able to see that it would simplify again. But I'm trying always to only simplify once if I can, right? Okay, so that's addition and subtraction. I'm going to back it up and try to focus on it. If you need to, my camera's kind of flop-eyed. It always is like not exactly square to the paper, so it's hard to get that right. Okay, I want to focus on this, and if you need to recopy anything, now's the time to pause the video and copy. But I'm going to flip the page, and we're going to do multiplication. Okay, just like the page before, I have already things written out here, so I'm going to focus on the top of the page. And I want you to pause the video and start getting this copied down. Let's just start right now by doing steps 1, 2, 3 here. And that's the bottom of the page is kind of different things, so we'll just start right here. Pause and copy the steps down, please, for multiplication. Okay, now that you've got the steps copied down, we're going to go ahead with our examples for multiplication. Multiplication is the easiest operation with fraction because you really don't have to do anything at all to begin with. All you have to do is multiply across, right? And so these steps are written out very clearly, but most people have a good understanding of multiplication. It's the easiest operation. Sorry, let me get my example here. We have 3/8, and we're going to use a dot and not an X because we're in algebra and X's always represent unknowns. So we don't want any X's in here confusing the problem. So we're going to use a dot or parentheses for multiplication, right? A dot or parentheses represents multiplication, never an X. So we multiply numerator times numerator to get the numerator answer. 3 times 7. Okay, I'm going to go back and highlight again. Step 1 is multiplying the numerators to get the numerator answer. 7 times 3 is 21. Step 2 is multiplying the denominators to get the denominator answer. So that will be 8 times 3, which is 24. And now our last step is to always simplify the answer if we can. We look at the lower number, 21, and we say, what will go into 21 and will it go into 24? Okay, 3 will go into 21, 3 won't go into 24. The next number that'll go into 21, 4 won't, 5 won't, 6 won't, 7 will. 7 times 3 is 21. Oh, wait a second, did I mess up? I sure did. 3 will go into 24, right? 7 won't go into 24, but 3 will. Okay, so we're going to divide by 3. Sorry about that. 3 is the highest number that goes into 21 that'll also go into 24. So 21 divided by 3 is 7. 24 divided by 3 is 8. So in the lower number, 7 is the only thing that will go into 7, and it will not go into 8, so we know we're done. Okay, multiplying is super simple. Now, one thing we're going to do a lot in algebra is have to multiply a whole number times a fraction. And you can turn your whole number into a fraction and use this method, but if we can learn a simpler way of thinking about it, it might make our math much quicker. Okay, so now I want you to copy down these next steps for whole number times a fraction, please. Pause the video and then we'll get to an example. Okay, so now you've gotten it written down. When you're multiplying a whole number times a fraction, and this is our second example, I'm going to use parentheses this time to indicate multiplication, so you can just have an example of both. Okay, 5 times 2/3. When you're multiplying a whole number times a fraction, the first step is to, if you want to avoid having to make the 5 into a fraction, which a lot of times we do because one will be a little more complicated than this one, so we'll want to do that. All we do is multiply the whole number times the numerator, and that will give us the numerator of the answer. 5 times 2 is 10. The denominator doesn't change here. Okay? And in essence, that's because we really would put a 1 under the 5, and so 1 times 3 would still be 3. Okay? But with a whole number, we can just think of it as the denominator doesn't change. Right? So now we have 10/3 as our answer. The first thing most people think is that's improper, right? And you have the urge to change it to a mixed number, but we're not going to change to mixed numbers. We're only going to see if it will simplify by division. 3 is the only number that will go into 3. Will 3 go into 10? No. So we can't simplify that, and that is our answer. Okay. All right, we're on track with 22 minutes. We're going to do division right quick, and then we're going to be done. Let me back up on this page just in case anyone didn't get everything written down. I'm going to try to focus here. If you need to pause and get anything that you missed written down, do that now. Okay, I had a little glitch in the video, but hopefully we're picking up exactly right. We are on to the next page, or you might not be, right? So you don't have to keep up with me page for page. You should just fit whatever you need on your page. You might write smaller or larger than me. But I am on the 3rd page of my notes, and so I've given it the same title again, and over here I've just it's still number 1, right? Every page I'm doing with this title is number 1, okay? And we're on division right now. So pause the video and copy down the steps for division right quick. I do have this little underline in green right here, and we are going to write something else over here, but we'll do that while we're taking our notes, okay? Okay, division also does not need a common denominator. Division is the opposite of multiplication, right? So just like addition and subtraction are opposites, multiplication and division are opposites. And this is really helpful in multiplication and division because since division is the opposite of multiplication, we can use that idea to change division into multiplication by using something called the reciprocal. So step 1, change division to multiplication by the reciprocal. And the reciprocal has a definition which we want to put over here. The reciprocal is, a lot of people will just say the flipped over fraction, but it's really the inverse, right? We invert the fraction, which means we flip it over. That's basically what it means. I'm going to just put examples here because sometimes that's more helpful than a definition. The reciprocal for 2/3 is 3/2. So you just put the denominator on top and put the numerator on the bottom now, and that's your reciprocal. Some people have a harder time when we have a unit fraction, like 1/2. 1/2 flips over to become 2/1, but I'm not even going to put over 1, right? And this is why some people have trouble with it. It's easier when you invert 2 over 1 to just put a 2, because any number with a 1 on the bottom is a whole number. So just leave it as the whole number right when you invert it, and it will make your math easier. People have an even harder time when they're starting with a whole number and inverting it, right? You need to remember that the thing to do to help you invert it is to realize that 3 really has a 1 on the bottom. So if you are to create its reciprocal, the 1 will go on top and the 3 will go on the bottom. Okay, so those are some special cases, and I wanted you to have those written here because sometimes that's what you have trouble with. You're like, wait a second. And then you can say, oh, that was in my notes. That's how I do that, okay? So division, we don't need a common denominator. We're going to change multiplication by the reciprocal, change division to multiplication of the reciprocal, and then follow the multiplication steps, which were, as we saw, super easy. So our first example is 9/3 divided by 2/3. Now, we're doing an example with this little division symbol, but in general, with algebra, we don't use this symbol. We're just doing this as a first example to remind you that when we do, sometimes people get confused with integer rules and then this division rule because they have learned with addition and subtraction to change subtraction by doing like keep, change, change, right? And sometimes teachers teach this as keep, change, flip, but then that kind of gets confusing because it's so similar to the other one, right? But it is true. The reason teachers teach it that way is because one of the biggest mistakes students make is that they tend to change this first fraction, right? But the first fraction in a division problem always stays the same, right? You never, never, never change the first fraction. Okay, when you're changing division to multiplication, the first number doesn't change because you're not even to the division yet, right? Once you get to the division, it's the division symbol that causes you to make the change. So you're changing division to multiplication with a dot, and then we're changing the fraction that comes after to the reciprocal. Okay? So this is how we change the problem. Never change this one. So we're going to keep it the same, right? That's where the keep comes from. We're going to change, and I already messed it up. We're going to change division to multiplication symbol, and we're going to invert or use the reciprocal of 2/3, which would be 3/2, right? So the steps for multiplication were to do numerator times numerator to get the numerator, and denominator times denominator to get the denominator, right? So 9 times 3 is 27. 3 times 2 is 6. Now we look at the smaller number and see if we can't simplify. Sorry, I am going back right quick because I want to make sure that I highlight the first step, which I didn't do. First step is to change to division, and I'm highlighting the parts that are changing. Right? Change, we changed only those parts. The steps for multiplication I had highlighted with orange and pink, so they're not really written out here, but that's what I'm doing. And the last step is to simplify, which I failed to write over here, so I'm going to go ahead and add it back. Okay, so I can simplify 27 over 6 because I look at 6 because it's the lower number, and I say, what will go into 6? 2 will go into 6, but that's not going to go into 27. 3 will go into 6. Will 3 go into 27? Yeah, 3 times 9 is 27. 6 goes into 6. Will 6 go into 27? No. Okay, since 6 won't, 4 would be the largest, 3 would be the largest one that will go in. So we're going to divide the top and the bottom by 3. And that's our simplification step, which I had been highlighting in yellow every time. So 27 divided by 3 is 9. 6 divided by 3 is 2. Now remember, that's improper, but since we're going to be working mostly in algebra, we're not going to change it to a mixed number just yet. We would completely solve the algebra problem before we did anything like that, okay? All right, we're going to do one more. where I show you a more algebraic way of writing division. And that is 7/12 divided by, with a fraction bar, 3/4. Now, this is a fraction divided by a fraction, and sometimes people come into my class and don't know that a fraction can have fractions on the top and the bottom. A fraction can have decimals on the top and the bottom, right? Because a fraction is really just a division symbol, right? 7/12 is really 7 divided by 12. That's how you turn the fraction into a decimal if you wanted to. Now, we're not turning things into decimals here. We're just operating with fractions. Okay, so this fraction on the top is getting divided by this fraction on the bottom, right? So the part we're going to change is the division bar is going to change to a multiplication, and then the fraction is going to change to its reciprocal. So I'm going to write this problem out now for my change, keeping the first or the top fraction always the same, 7/12 times 4/3, because I remember I'm going to invert it. And now I'm just going to use my fraction operations. Top times the top equals the top for the numerator, and the denominator is bottom times bottom equals bottom. So I got 7, 14, 21, 28 over 12, 24, 36. Okay, I do see right away that both of them are even, so that I can simplify by dividing by 2. But I'm not sure that's the best number, right? I'm going to check, so I'm going to look at the 28. I'm going to say, what's the next number that will go into 28 that will also go, that might go into 36? So 4 will go into 28, okay, because we just multiplied 7 times 4. Will 4 go into 36? Yeah, 9 times 4 is 36, okay. What's the next number that will go into 28? Not 5, not 6, 7 will go into 28. 7 won't go into 36 though. 14 will go into 28. Will 14 go into 36? No. And if you need to use a calculator to check those things, you can. Okay, so I am going to divide by 4 because that was the biggest number I found. And remember, I can check after I do my division. So in case I didn't get the biggest number, I can still simplify again. But if you find the biggest number, you won't have to do so many steps. So 28 divided by 4 is 7. 36 divided by 4 is 9. 7, the only number that will go into 7 is 7. And that won't go into 9s, which means I am done with my division. Okay. All right, that's all we're doing for now. Here's the sign-in code for your assignment. You guys in second period and third period are watching the same video. So you have to say, are you in second period or third period, to figure out which Delta Math to sign into. Okay, you just go on your computer to deltamath.com. It will first ask you to join the teacher's class, right? And so you put in my teacher code. Once you put in my code, you'll have to pick which class you want to be in. So you're either going to pick second or third period there. That's pretty simple. Your assignment has 3 parts to it. It has 5 adding and subtracting problems that are pretty simple. 5 more adding and subtracting problems that are a little more difficult. And then 5 division problems, multiplication and division. Okay? With Delta Math, here's how it works. You have to get 5 problems right. So for each section, and there's 3 sections, so that's 15 problems that you're doing for this assignment. You have to get 5 right. So when you start doing the addition problems, if you get the first one wrong, you still have to keep going until you get 5 right. So you get the second one right, you got 1 right. You get the third one wrong, okay, so you still got 4 more to get right. You can do as many problems as you need to do until you get 5 right. And since it's set that way, it will tell you you're done once you get your 5, right? And then it'll move you to the next section. Now, if you get 4 out of 5 right and you stop, you're not going to get 100. You have the option to get 100 on this because all you have to do is keep going until you get 5 right in each section and you'll have 100. If you stop without getting all 5 right, you're going to get less than that for the grade. Delta Math does tell you if you get the problem wrong, it'll show you how to do the problem right. So pay attention to that. A lot of kids really like Delta Math because it helps them when they get it wrong to see what exactly they did wrong, okay? Feel free to text me or call me if you have any problems figuring out what to do on Delta Math, and just know that just keep going until you get 5 problems right in each section and you'll have 100, okay? Have a good day, guys.